So usually wintertime for me means repairing or updating or maintaining some of my equipment, and as it turns out also repairing a common household object like this room heater, right? But I can promise you that for now at least I'm more or less done with repairing stuff or upgrading stuff, and from the next episode on I'll do another series of vintage restorations. In fact, I can lift a tip of the veil by saying that next episode will be a short video on repairing a vintage amplifier. So there you go. I hope you'll enjoy the video. Welcome, sit back and enjoy. Hello and welcome to my channel TechneMoira. In today's episode we're going to upgrade a Variac and we're going to repair a room heater. I want to give a small warning to those of you who would follow along with me in the video. The appliances I'm going to either repair or upgrade are all powered with AC, raw AC, and that may kill you if you don't know how to handle this kind of appliances. So if you're not sure how to work on this kind of devices, then rather don't, or ask the help of a qualified person, okay, or read up on the subject. But either way, if you follow along with me in the video, you do so at your own risk. I will upgrade my trusty Variac, which I have had for a number of years, and I will try to repair this little heater blower which suddenly stopped working. Apparently, according to the statistics, there are not that many people who like to watch a long video, so I'm going to try to keep it snappy, right? So this is my trusty Variac. I've had it for, I'd say at least 10 years, if not longer, and it never failed me. But the moment has come, I believe, to give it a little bit of cleaning, and at the same time, since I'm going to open it up anyway, I'm going to take the occasion to upgrade it too. Now, as you can tell, the Variac has an analog voltmeter. Yeah, it's just a voltmeter, very simple one, which indicates roughly which voltage is to be found at the output of the Variac, right? The Variac itself, I don't think, but we'll have a look immediately, is earthed. So what I wanted to show you is the voltmeter on the Variac, and as I turn the knob, yeah, you'll see the analog voltmeter go up. Alright, so it's reasonably accurate. I mean, let's see if I can show you how accurate it is. Alright, so here we go, volts, and let's put it on AC. There you go, AC volts. Alright, so okay, so now the Variac is at its lowest setting, and the voltmeter indicates a bit less than a volt, so 873 millivolts in fact. So let's go up to 100. Okay, 100. There you go. But this is 100 volts, and as you can tell, the analog meter is reasonably accurate. Okay, so let's go up to 220. There you go. So you can tell the analog meter is quite accurate, right? So maybe you'll see this faint little red stripe I painted on the front of the voltmeter. That should indicate 116 volts right here. Okay, so let me see. Like this should be, no, it's more like 122 volts. Okay, so that on the other hand is not accurate, and it's for that sort of thing that I want to upgrade my voltmeter here, my analog voltmeter, with this. Alright, with a little panel meter like this. You can get them like this as well, round, but somehow I thought this would look way better. Yeah, since the front of the Variac is all square, a square panel meter would be nice, right? So there you go. Oh, and if you're curious about the specs, this little thing here, let me take it out of the box and show you close up. This little thing came not only with the meter, so it's like this, okay, but I also picked the display color to be blue. Alright, and it also came with this, and this is the pickup ring, which will allow me to measure the current on the output of the Variac, which of course there is none as yet, right? So the specs of this really is that it goes up to 500 volts AC, if I'm not mistaken. Let's see, oh yeah, it's spec'd out between 60, I think, and 500 volts AC, and between 0 and 100 amps. So here you go. If you want to read the specs yourself, here they are. Alright. Alright, let's undo the front panel. Don't worry, I disconnected the Variac, and there's absolutely no power on it right now. Okay. Okay. Ooh, this is not good. Let's see. Let's see if we can take this out. Yeah, we can. Alright. So what's inside here? Okay. So there you go. This is what's inside here. Okay. Alright, now the knob. There you go. Wow. Now that's a big knob. Very massive knob. Almost feel like I'm going into a bank vault. Alright, so here's the spindle of the Variac. Right. I've released all the screws of the casing, so I technically should be able to lift it up. Yeah. Unless, of course, after all these years it got stuck to the bottom. There you go. Voila. There you go. Now, if you're curious about the specs of the Variac and its brand, this is it. So it's rated from 0 to 250 volts, one phase obviously, 50 or 60 hertz, and a maximum of 4 amp or 1000 voltage amps. Okay, so the brand is Hosoni. Don't ask me where that company is located, but I'm sure some of you will find out where it is. And that's the inside of the case. It's reasonable. I mean, it's not... Back in the day when I bought this Variac, it wasn't like a top of the line model, but back then that's all the money I had to buy, you know. So yeah, not bad. The paint job could have been better, but I mean, it's not exposed to the elements, so it will more than likely never rust. Okay, I vacuumed and cleaned the innards of my Variac, and I took it apart as far as I dare to. I mean, I don't want to take it completely apart. There's no sense to that. There's no use for that. All I want is it to be mechanically and electrically sound and clean, and that's it. So to clean the windings of the Variac, and specifically the top where the electrical contact, which is this here, this part right here where my thumb is, slides over, I used contact cleaner, and I'm not sponsored by the brand, but I want to show you which one I use. It's called Manuel, and it's type contact cleaner 9893. I've been using this stuff for years, and I've never had any complaints about it. It's good stuff. Not the cheapest, but not bad. Okay, so, and then, yeah, for the mechanical, the purely mechanical part of the Variac, I used stuff you all people know is WD-40, right? Okay, I use foaming spray to clean up anything mechanical inside and out, for two reasons. WD-40 is water repellent, which is perfect, and it cleans off any greasy residues quite easily, yeah, which is perfect. So okay, this is the slider contact of the Variac, and like, as you can tell, I totally unmounted it, and it's a kind of a bracket, I would think, in a sort of hard plastic, which is connected to via a braided wire, copper wire, to the center point, the distribution point, you could say, where the power goes to the output. Yeah, the selected power goes to the output, right? And it's this point right here. So the braiding, you see, together with the eyelet to which it is connected, and the holder and the slider contact, the whole thing is one piece. Yeah. I felt whether I could remove this part here, which seems to be brass, clamping a very thin sliver of carbon. Let me see if I can show you close up. There. Okay. So this piece here is, as you can tell, is a sort of brass clamp into which is clamped a piece of carbon. Apparently they surrounded it with solder, I'm guessing to improve the electrical contact. But yeah, I mean, I gave it a little push. I didn't want to be too aggressive, but I think this part here is clamped into this plastic holder, and if I ever would have to replace it, I would have to replace this whole thing. So not just the brush, so to speak, or the contact, the slider contact. And the whole thing fits right into this bracket here, like that. Okay. It fits right in here. Okay. And it's kept down, yeah, with a spring. And the spring is down here. Okay. So with that spring here. Alright. So this spring is held down by a little plate and two screws, okay? Two Phillips screws, and that's it. And that pushes down this whole assembly here with the carbon contact onto the coil of the Variac, right? So, and that of course in turn, when it slides, selects the right number of turns of the Variac to output the desired voltage. A Variac is not like a variable resistor. I mean, it would be tempting to compare a Variac to a variable resistor somewhat, but it really isn't. I think it's more like you could say a buck converter, yeah, like a spool, which offers, the bigger the spool is, the more resistance it offers to AC voltage, right? And therefore you can select which kind of voltage you want to go to the output, yeah, by selecting the number of turns of the coil you want to put between the AC inlet and the output, right? Alright, I completely disconnected all the wires going to the Variac, as you can tell, and I've done a little bit more cleaning inside and out. I also cleaned the casing somewhat. Okay, I mean, it doesn't look brand new, but it looks certainly a lot cleaner than it used to, right? Also, I've been drilling a few holes for the additions I'm going to put in the Variac, right? So one opening, this will be the opening for the fuse holder, which is right here. Okay, so this will be the fuse holder, and then I drilled two holes, slightly smaller holes, which I need to file a bit bigger, and that will become the space for the on-off switch, because I decided that I wanted an on-off switch on it as well, and which will be this one here. The switch is rated at, let me see, the switch is rated at 6 amp 250 volts, alright, so which is ample, which is more than enough, because the Variac itself is rated only for 4 amps 250 volts, right? So and the fuse holder is, if I'm not mistaken, has the same rating. Let me see. Oh, even better. The fuse holder is rated for 10 amps 250 volts. Let me see if I can, yeah, show you there. You see? 10 amp 250 volts. Alright? So it's important that you select parts which preferably, of course, are equal to the capacity of the device itself. So in this case, the Variac, right? So, but of course, the parts that you mount inside should never be less than what the Variac can source, right? So if you ever draw more than 4 amps, say, and but your switch wouldn't be able to handle 4 amps, you could cause a fire, right? Because the switch could overheat and then catch fire. So it's very important that you always select parts at least equal or better than the device in which you mount them. Also, and that really angers me a little bit, I can't say how many devices I've opened in the past that where there were absolutely no fuses inside. I mean, I know why they do it. The suppliers, they just want to shave off a few cents of the cost of building their appliances, and that way make an extra buck when selling them, right? But I mean, I believe, at least in AC driven appliances, which are probably 90% of all of our appliances in our home, I believe that they should at least have a fuse, yeah, as a protection, as a sort of an insurance, right? So yeah, I am going to build in a fuse holder. It's long overdue. I should have done this 10 years ago, but okay, now I have the time, so that's when it will happen, now. By the way, test fitting components inside let's say an enclosure which already existed, so which I'm doing right now for the Variac, cutting holes and taking measurements and then fitting the parts inside, is a technique called moulage. By the French, right? So yeah, it's actually an old method of building something around other parts, foreign parts. So it's called moulage, or test fitting components into an existing old cabinet, you could say. Alright, the front panel has been prepped and painted, and I chose to go with neutral gray which seems like appropriate for a front panel. You don't want to be distracted by the front panel, but you want to rather focus on what's really important, right? Now there is one strange thing that happened to it. When I covered it with a last layer of paint, the paint sort of crazed all over the front, and only the front, not the sides, by the way. For some peculiar reason, yeah, you see, the paint crazed all over the face of the front panel. Okay, it gives it a bit of a peculiar look, which not too bad actually, but yeah. If you ask me why this happened, I am a bit mystified myself. I would say probably because the layer that went before the last one wasn't entirely cured. And I think that is the reason why the last layer has this strange crazing go through it. For those among you who may be interested in mounting the same type of panel meter to some of your equipment, I had to replace the original current pickup, which is this. Yeah, this is basically a spool through which the wire runs here, through this opening here, through which the current goes, right? Now the spool, this is the spool that was originally supplied with the meter, but it turned out not to be very sensitive. I mean, especially for current measurement. The meter in itself, I think, is not very sensitive, but if the spool doesn't pick up enough signal, let's say, so enough of the magnetic field created by the passing current, then the meter will not really function, yeah, will not indicate anything. So I replaced the pickup coil by another one which I had in my parts cabinet, and it's this one. Alright, just in case you would be interested in using exactly the same panel meter. Alright, before I'm going to mount back the enclosure on the Variac, which I just gave a thorough cleanup, but nothing more. I wanted to show you how the front panel of the Variac looks now. And I mean, except for the obvious change in color, what changed really is the addition of a fuse, an on-off switch, and of course a digital panel meter instead of the original analog meter, right? So how does it look on the inside? I'll show you. So this is how it looks on the inside. It's a bit crowded now, I have to admit, but it works. I tested it and everything works. So the obvious things you see are the pickup coil here, you see, to measure the current that goes through the output wire here, this one. Then the backside of the meter itself over there, yeah, which sticks out but not much, maybe by 3 or 4 millimeters, so which is fine. I mean, there's enough space behind it to take that. And then of course there's also the outlet you see down there, and then the switch is buried down on the other side behind all the wires that connect everything. Okay, so there you go. That's how it looks now. So all I need to do now is mount everything back. So, well, I need to mount back the cabinet of the Variac. Then, well, obviously I have to take off the knob first, then mount the front panel, and then mount back the knob. And then we're done. Alright, the Variac is reassembled and completely ready for use. So I, just for giggles, I connected a hair dryer to the Variac, and we're going to give it a test run, as it were. So okay, let me switch it on. Alright, it's on now. Now let's turn the power up to around 220 volts, which is what the hair dryer needs, right? So, okay, up we go. By the way, the frequency of the AC in my country is 50 Hertz. Okay, here we go. Almost there. 224 volts I need. There. Alright, now let's switch on the hair dryer. Actually, no, this is the low setting. This is the high setting. I can't go too long over 2 amps, okay, but there you go. This is intermediate setting on the hair dryer. So there you go. It works perfectly. By the way, apparently there seems to be an ongoing discussion on forums and other talk groups on the internet. Where would you place the fuse, right? So this is a fuse holder here. And where would you place the fuse in an appliance, right? Would you place it before the switch or after the switch? I don't rightly know why people seem to have trouble with this, but okay, to tell you, I placed the fuse before the switch, and the reason for that is that I want the very first thing to blow if there's a short of some sort. The very first thing that should blow is the fuse and not the switch or the panel meter or, you know, the Variac itself. So yes, in this Variac the fuse goes before everything else. Alright, next patient on the slab is this little heater which suddenly stopped working. It's a fairly good little heater until, well, that is recently when it stopped working. But yeah, I need to figure out what's wrong with it. I have an idea where it might have gone wrong, but let me show you what possible causes I think might be at the source of the problem. Alright, so I identified 6 screws at the back that need to be unscrewed, and as far as I can tell they are fairly standard Phillips screws, so crosshead screws, you know, which you can unscrew with a screwdriver like this. Alright, so it turned out I needed to unclip the front panel, you know, so this panel here. Alright, from the top part here there are 3 clips here which really hold the front part onto the rest of the body of the heater, and this is the inside really. So I don't know if you guys can see this, but let me zoom in a bit. So at the top you have what I surmise is a power supply right there. I think I see 2 relays. Yeah, and I see, which I can't make out. Let me see. What is the IC? I don't know what kind of an IC that is, but I would say that's possibly a temperature regulation IC, or maybe a power regulation IC. Either way, I don't know. I don't rightly know. And then at the top you have the display and the control panel. You see it over there, right? I see right away a couple of ICs mounted to the bottom of the PCB, but I don't see anything which would be obviously damaged or burned. So yeah, it all looks okay to me. Now let me see. Yeah, the on-off switch is down there, right there. Let me show you. So the power switch is down there. This is a power switch here. So what I'm going to do, because I have an inkling that that might be the cause of the trouble, so let me take it out and have a look, you know, measure, or let me disconnect it rather and see if it is causing a problem here. Okay. Oh yeah, okay, I see it's one of those spade connectors where you probably need to push to disconnect it. Okay, so give me a moment to disconnect the switch and I'll get back to you. Alright, I unmounted the on-off switch. Okay. And it was indeed connected to spade connectors with a little tab at the back, yeah, which prevents the spade connector from shaking loose. Right, so you need to pull back this little tab in the center to actually disconnected from the switch. Now I measured the switch with my multimeter, and indeed the switch seems to be broken. Let me show you. So I put my multimeter on ohms. So let me put the camera back on the tripod and then I'll show you. I measured it with my ohms, well, my multimeter, and it doesn't seem to function. So this is in the off position, and that's normal. It should read open, right? Okay, so my multimeter works. Okay, now let's put it in the on position. Nothing, right? This is in the on position. Okay, so yeah, as I predicted, it's the on-off switch that stopped functioning. So I found something inside the heater which worries me a bit more than the failing switch. So remember I told you about the safety switch at the bottom of the heater, right? So if it falls over, the switch releases and the blower should, or the heater should immediately cut off, right? It's a required safety. Now the power wire, let's say the AC power, goes to the safety switch via this connector here and comes out again and goes to the rest of the device or the appliance via this connector here. Alright, so, and the on-off switch is in between. Okay, now if you take a closer look at the wires going to the oscillating motor, okay, so the heater can oscillate left to right to heat the room. Yeah, have a look at the wire here. Right there. Are you seeing what I am seeing? Right there. Okay. So you can actually see the conductor here. So while this device was oscillating back and forward, it obviously rubbed against the insulation of the wires, and rubbed away the insulation. And look, this is the other wire. Okay, right there. You see, right there. So this is troublesome. Okay, so I need to have a look at this and see if I can somehow fix this, rather than, you know, throwing it back together again and that's it. Yeah, this is something that I need to address, because this is a potential source of trouble. I opened the foot of the heater, not only out of curiosity. I wanted to see how the oscillation happened, and it's apparently with a small electric geared motor and a small plastic gear, you can see here, yeah, which oscillates back and forward into this slot right here. Okay, so it goes back and forth in this slot here, which in turn makes the foot rotate left to right, about 70 degrees, at least that's what they say. Okay, and also I was curious to see how the switch looked, the safety switch, you know, which pokes out of the bottom of the heater and allows to an emergency switch off of the power whenever the heater would tip over, right? So yeah, and when I found the switch inside, everything was not okay. In fact, it was so bad I had to repair it with epoxy, as you can tell. Well, I'll show you. Alright, so there I had, it's not pretty, but it's sturdy. Yeah, I had to repair it with some epoxy. So yeah, good thing that I opened up the bottom of the foot of the heater, and I took the time to repair the wiring. The same thing, the same remark here. It's not pretty, but it'll work. Okay, so let me show you. So I repaired the wiring with heat shrink and Kapton tape where it was damaged, and well, as I just finished saying, it's not pretty, but it's functional, and at least it's a whole lot safer than how it was. Now, the damage was to the wires, I mean, was caused by that same oscillating movement which is produced by this electric motor here, this geared motor here. Now, it's just unsafe. Okay, it's totally unsafe, and I slept on it. I looked at the foot of the heater from every possible angle if I could improve on the design, but in a safe way, and I came to the conclusion that actually there is absolutely no way I can make this safe to use with the oscillation function, and therefore I decided that the safe course of action is to simply cut the wire to the motor and leave it like that, you know. So it's just, I would say, it's the safest thing to do. Alright, there you go. The switch is mounted back in place. Now we can close up the enclosure for the foot and then move on to the rest of the heater. Alright, the foot is reassembled. Okay, and it's ready to be mounted back inside the case. So there's only one more thing for me left to do, and I have to admit it's with utter reluctance that I do it, but it's really the only safe way to use this heater, and that is to snip one of the wires, or both I should say, to the motor, right? But I'm only going to snip one, which is the yellow one. So there we go. That's the only safe way to do it. So I'm going to cap off the wire that I snipped through, at least on the end where the power would come through, with some heat shrink, and that's it, you know. Really, let's call it what it is. It's a bad design. The intention was good, but the design was really poorly executed. And there you go. I condemned the wire to the motor permanently, and I heat shrinked it on both sides. So you can see over there the other piece of the wire. So I folded it double and then encapsulated it with heat shrink. So the motor is permanently disabled. As much as I hate to lose that function, it's probably for the best. Alright, and there you go. The heater repaired and exercised, and then the Variac, which has been upgraded with a new meter, a switch and a fuse, and a small paint job. So let's see if the heater works. Let's switch it on. Well, the display says yes, it's on. So let's see. Oh yeah, there, on medium heating. Yes, it's starting to warm. Yes, it's starting to warm. And on full heating, oh yes, yes, it's definitely warming. Okay, so that's great. So both are repaired. So there you go. I upgraded my old trusty Variac, and to bring it up to date to the 21st century, building in an on-off switch, a digital panel meter and a fuse. Now, I also repaired this nice little room heater, but one word of caution: if you bought exactly this model or a very similar model, I would advise you to either have some qualified person see whether the wiring in the foot of the device is still okay, because as you remember in the video I showed you potential sources of fire hazard, right? So be aware that it's certainly not perfect, but with some minimal intervention it can be made safe and usable. Either way, both devices work on raw AC power. If you're going to follow along with me in the video, you do so at your own risk. If you don't feel confident working on stuff which works on AC power, ask somebody qualified or read up on the subject first. Always use the appropriate means to keep yourself safe. So there you go. This is the end of the episode. I hope you enjoyed it, and I'll see you soon for another episode on my channel, TechneMoira. Thanks for watching.